All right, so one more graph, just because we can never get too much practice with our logarithmic functions. This time I'm going to make the base a fraction. Now, if you remember when we graphed exponential functions, when the base of the exponential was bigger than 1, we got an increasing function. It was called exponential growth. When my base of my function was between 0 and 1, I got a decaying or a decreasing function. So the question then is, how does the graph change when I make the base a half as opposed to 2? That was our first example. We graphed log base 2 of x. You can look back to that to compare as we go. So I'm going to put the same values, and I've just reversed their order here. These are all powers of 2. Since a half is based on 2, that's why I've picked all powers of 2 here. So here we go. I'm going to start at the top. I've got log base half of a half. So a half to the first power gives me a half. And then log base half of 1. Well, anything to the 0 power produces 1. Remember, our logarithm produces a power. That is always the output. And then the log base a half of 2. Well, notice a half to what power produces 2? Well, I've got to flip the base. So -1. And then log base a half of 4. Well, again, I've got to flip, so it's going to be negative, and then 2 times 2 gives 4. And then last one, log of a half of 8. Once again, since my base is a half, in order to produce 8, I've got to flip it, and then 2 times 2 times 2, or 3 is 8. So there are my points. Now we're going to go over to the graphing board. So I go over a half, and I go up 1. I go over 1 and 0. Then I go over 2 and it's -1. I go over 4 and it's -2. And I go over 8, so 2, 4, 6, 8, and I go down 3. Once again, I have a vertical asymptote here at the y-axis. And so you see that my graph now is a decreasing function if you compare this with the log base 2, which was an increasing function. So one more time, because we've done this with each of them. So this is the log base a half of x. Last thing we're going to do is one more transformation. So in orange, hopefully this shows up. Great color. I'm going to take the log base half of x, and then not in parentheses, I am going to add 4 on the outside. Some of the problems in the book, they will put the 4 in front so that you don't confuse where the 4 is. But what tells you that this is not being added to the x is the fact that there's no parentheses. Whichever way you write this, what I'm going to do is I'm going to take the original graph and I'm going to move it up 4 units. So this point here that was at 1 goes to 2, 3, 4, 5. This point that's at 0 goes up to 1, 2, 3, 4. This point that's at -1, 1, 2, 3, 4, goes up to 3. This point that's at -2 goes up to 2. And then this point that's at -3 goes up to 1. And we get the same graph. We have not shifted the graph left or right, so the vertical asymptote stays right here on the y-axis. That does not change. And there is my graph that's been shifted up 4 units.